So reference angle in the third quadrant. So what I'm going to find that quickly. Tan inverse of 4, by the way, is my mode in degree? I think it is. Yes. Okay, so the 4 divided by 3, 4 divided by 3, close parenthesis. When I hit enter, I have 53 approximately. Let's make it 53 only. Okay, now I'm going to write it in. So I have R as 5 and I have theta as 53. The angle is in the fourth quadrant. How do I know that? Because if I plot this, I have the angle in the fourth quadrant. Therefore, the reference, so I actually just found the reference angle. The angle in clockwise direction, counterclockwise direction is 360 minus 50 minus 53. So 360 minus 53 is the angle in question in positive direction, and that angle is 307 degrees. Okay, so quickly I am going to write this in. 5 is R, I can put parentheses, cosine of 307. This cosine is positive in the fourth quadrant. Then I'm going to put negative here. Why? Because the angle is in the second quadrant. Sine is negative in the fourth quadrant. So negative sine, and I should be here, sine 307. And if I'm told to write it, or I can write my answer is as Z equal to 5 C's 307. Okay. So in other words, I can complex number in rectangular form. I can convert it to polar form or trigonometric form. So let's go to number 10. Number 10, and this is, we are doing powers. So let's work on powers. And after we work on powers for some time, we get into De Moivre's theorem. So De Moivre's theorem worked on powers of complex numbers. All right, so the first thing I have to do is number 10. I can do it by ordinary foiling. So in number 10, I have 2 minus 2i squared. And I cannot rewrite, I can just rewrite it as 2 minus 2i multiplied 2 minus 2i. All right. Now that I have done it this way, I can FOIL. So foiling it, I have this multiply this and this multiply that, and I get an answer. So 2 times 2 is 4. 2 times negative 2i is negative 4i. Negative 2i multiply 2 is negative 4i again. Negative 2i multiply negative 2i is positive 2i squared. Remember in your junior class, Math 110, we talked, I don't know if your class, but I remember we talked about I squared is equal to negative 1 always. I to the power of 4 is equal to 1. So when you get to powers of I, you should be able to, okay, let's talk about, quickly talk about, not to, I won't take too much time because we have some things more important to do. Suppose I have evaluate I to power 9. Right now, I already know that I to power 4 is 1. So I can say I to power 4 multiply by I to power 4, multiply by I to power 1. And since this is 1, I won't worry about that. This is 1, and this is I, so my final answer is I. This is just a quick review. Well, suppose I am told to evaluate I to power 99. Well, let me just get a number that is. Everybody knows that. Let me say I to power 86. Okay, this is good. I to power 86. So I will start finding, but I already know that if I divide 86 by 4, I have 2 go here. So I have I to power 4. I to power 4. How many times? If I divide by 4, I have 2 here. If I divide, so I have 21. Then multiply by I to power 2. 21 times 4 is 84. Then plus 2. I to power 2, I already know it is -1. Any powers of I to 4 is 1, so I won't worry about that. Therefore, I to power 86 is the same thing as -1. That is, by the way, I just reviewed powers of I. That way you can, I hope you remember that. All right. So let's go back to what we were trying to simplify before. So now we go back to number 10. Is it number 10? The number we're talking about. Let's go there. Okay, so collect like terms together. Everybody remember that we multiplied 2 multiply negative 2i multiply negative 2i. We have positive. And then we have I squared. So because we know that I squared is -1, I want to rewrite. So if I rewrite this, I have negative here. Let me just put negative here. Okay, so, and then I want to write -2. Okay, so that's -2 finally. Collect like terms together. 4 minus 2 is 2 minus 8i in standard form. So I have written this number in standard form by foiling. But guess what? You will not be able to foil all the time. You won't be able to foil all the time. Okay, so we want to redo number 10 using multiplication formula. So we are going to powers of I. The Morpheus theorem discovered how to evaluate powers of I. So we are going to talk about it now. If a complex number in polar form or trigonometric form, suppose I have Z1, and Z1 is 5, 6, 30 degrees, and I have Z2 is equal to 4, 6, 45 degrees. If I'm told to multiply Z1 by Z2, talking about Z1 multiply Z2, so Z1 multiplies Z2 will be, first of all, what you are going to do is, if you have this, you got to add them up. So first of, in this one, let me make sure that we have, so we are multiplying. So I have 5 multiply 4 into, I'm going to expand. This is cosine of the first angle plus the second angle. In other words, you add inside. You have to obey all the signs of um, the unit circle, I sine angle 1, theta 1 plus theta 2. So you rewrite 5 times 4 is 20. So the modulus of Z1 multiply modulus of Z2, and then cosine of Z1, angle Z1 plus angle Z2. Remember, you're multiplying. So modulus multiply modulus whenever you're multiplying. Angle plus angle. All right. So I have 70 degrees here plus I sine 70 degrees. Okay. All right. So let's go to one that is longer. Maybe can we start from number 9? Let me see if another one is shorter. Start from number 9. Find the cube root. Now we have to raise the number to the given power and write the answer in rectangular form. No, we have already done something like number 4. Okay, well, we need to do something like number, all right, number 1 is good. Let's go to number 1. Everybody, I just explained number 1, by the way. So as we do this, we are actually applying powers. But the Movers theorem says if I have n, okay, that's one called n1. That's n1. Suppose this is n is equal to whatever the number is. If this is n, you can now say that n squared, you multiply that n squared into cosine of n times the angle in the middle. Okay. Plus sine of n times angle in the middle. Okay. All right. So now let's multiply this. And actually, we can go look. You can to be sure. Let's go to 11.5 quickly. And so we will just take ourselves to 11.5. Peep in the Movers theorem. See and then come back and continue our homework 11.5. So quickly to 11.5, just see an example and then be able to do the Movers theorem. Powers of complex number, roots of complex number. Okay, and I'm going to just get to where it is without going through one by one. Okay, and I think there are some parts. Okay, so we just did one, we multiplied. When you are given a power, you multiply, that's what we just said. Multiply the modulus by modulus, all right? So remember we expanded it, but now we multiply modulus by modulus, and then you add angle by angle. This time they are the same angle, but even if they are different angles, you still sum the different angles. You multiply modulus of Z1 times modulus of Z2 and angle of Z1 plus angle of Z2. That's what it says. Okay, the Movers theorem, the same thing is about complex numbers, and n is any real number then. Okay, so the Movers theorem is that if you are told to expand any number raised to power n in compact form, you can write it as r is theta to power n, but you don't have to write compact form all the time. All right, alternatively, you can use what we just did. So 1 plus I root 3 raised to power 8 is equal to, bring down the equation. Now raise r, the modulus, to the power, and then it's just like adding 68 times. So multiply. So we have seen an example And so we are going to, and when you finish, convert your answer back to rectangular form. All right. But suppose you're given a rectangular form and you are not, you have to make sure you know how to convert rectangular form to real form. So let's go and do that in the homework so we can, in the practice test. So let's go to practice test. So we're going to do exactly what, so we already know how to do this. This is, already know how to do number one. So let's do number one again, even though we know how to do it. We already know how to do number one. So we are squaring. According to De Moivre's theorem, we square the modulus and we multiply the angle by the power. Multiply the angle by the power. Simplify, sign, then simplify. Okay, and 3 squared is 9. 2 times 30 is 60. Cosine of 60 plus I sine 60. And then if you want to write it in compact form, you write 9 C's 60. Okay. Well, let's do number 2. Following powers. We don't have to get to cycles of, we just need to make sure we know how to convert from standard, I mean, from rectangular to standard form, which is polar form. Okay, from standard form to polar form. When you say polar form this time in this section, it means we are talking about trigonometric form. Okay, so we can do number 2, even though it's in radian, the same thing goes. Right here is telling us that R is 1. They didn't give us R. R is 1. So I'm going to rewrite it and make sure that I put 1 there. 1 raised to power 3 cosine of 3 multiply that angle, pi over 3 plus I. I'm going to use parentheses here. Sine multiply that angle pi over 3. Remember, I got to multiply this angle by 3 also. And finish up. 1 raised to power 3 is 1. I have 3 cancel pi over 3. I got pi there. So that's 180 degrees. Plus, this cancels, so I have I sine pi. So I get my answer after the expansion. And so I can rewrite this as C's pi. C's pi in radian. Okay, if I write 1 here, I can write 1 C's pi. Okay, number 3, quickly, let's do number 3. Whatever you know in this section, make sure you know it very well. If you see it, you know it, you answer. And so that if you see something you don't know, you do not waste time with, especially in exam. In your final exam, in this section is already in exam. But if you see something you don't know it, and don't waste time with it, trust me, you don't need that. If you can do the ones you know and do it very well, you make a good 90. Make a good 90, you made an A. In fact, some of you don't even need A. Some of you don't need A to make an A in final exam. All you need to do good, and so that final exam will take over one of. All right, so let's go back to this question number 3. Question number 3, we have a complex number in trigonometric form or polar form, and the power n is equal to 6. So I want to apply De Moivre's theorem immediately. That's De Moivre's theorem. The power, how to expand this. It is already in polar form, so no problem. It's not a big deal. So I'll just start by 2 raised to power n, that's 2 times 2, 6 times, into big parenthesis cosine of n multiply pi over 3, 6 multiply pi over 3 plus I sine 6 multiply I over 3, pi over 3, sorry, pi over 3. And if I divide, I have 2 to the power 6, by the way. I get my calculator and make sure I get it right because I don't want to do anything in my head. So I'm going to get to turn my calculator on, get to caret 6. 2 caret 6, and I got 64. So 64 cosine of 2 pi, that's 360 degrees, plus I sine 2 pi. That's it. That's easy. All right, let's do number 4. In number 4, the original question is in rectangular form. So the first thing I have to do is convert, actually, we can actually expand this. We can actually, we have already done something like this. But if it is, let's get one that is in another form. Let's get done something like find the cube root. I'm not doing cube root of that for now. So find the graph of the cube root. First of all, you want to convert that function. Let's convert that function. Convert the function given to us. So we have got z is equal to negative 2 root 2 minus 2 root 2 I. Okay, and the first thing I want to find out is what is the modulus. So modulus is equal to square root of the real part, negative 2 root 2 squared plus negative 2 root 2 squared. Okay, and if I open that parenthesis, I have 2 squared is 4, 4 multiplied 2. 2 squared is 4, 4 multiplied 2 is 8. 2 squared is 4, 4 multiplied 2 is 8. 8 plus 8 is 16. Square root of 16 is 4. Therefore, I got R. R is equal to 4. I found the value of R. R is equal to 4. So we got the modulus, and so let's get the angle. So I want to use arctan. First of all, you notice that this angle should be, if I draw, I need to draw quickly, draw the, I'm going to put that vector. Let me put the vector up. That angle is negative, negative, so it is somewhere in the third quadrant. So the angle in question is an angle in the third quadrant. So when I find the value of tan theta here, arctan theta, then I should do, I should find the angle in the third quadrant. And that angle in the third quadrant will be angle minus 360 degrees, 180 degrees. Actually, 180 degrees plus 180 degree plus reference angle. Okay, so quickly, tan inverse of the imaginary part of that 2 over imaginary part. Question, somebody has a question? Let me see what your question is. Yes, question? Does anyone have a question? Anyone has a question? Okay, I thought somebody has a question. If you do have a question, you can ask. Okay, if you do have a question, you can ask. All right, so now so the tangent, arctangent is, so what is the angle? whose tangent is 1, and that is 45 degrees. I hope you agree. Remember 45, 45, 90. If I'm talking about this angle theta, it is opposite over adjacent. So 1/1, and so that is 45 degrees. So the angle is 45 degrees. And since the angle is in the third quadrant, it is 180 plus 45, 225 degrees. Excuse me. So 225 degrees is the angle. So the first angle there is 225 degrees. All right, so I have 225 degrees. So I can write RC is 225 is the first one. R is, or I can say 4. What was the answer? 4 is 225. And then you start adding. So when I grab the first one, then I start the multiples of 90. Start the multiples of 90. We can go back and go to this.